Hello, and welcome to the second lecture of Electric Machine Design using Ansys Maxwell series. In previous lecture, we discussed an introduction to Ansys Maxwell, its solver types, and detailed information on when the user should use which solvers. Proceeding further in this lecture, we will be covering the information about the Ansys Maxwell interface and the 2D modeling tools that we can use to create anything from basic to advanced level geometry to perform electromagnetic simulations. So without much further ado, let's get right into it. So the window visible on the screen is called ANSYS Electronic Desktop, also referred to as AEDT. AEDT is the primary platform for all electronics related module from ANSYS. This means that to open any of the electronics related modules, ANSYS first launches AEDT and then opens the respective module in it. On top left side of the corner, we are seeing is called pull down menus. So clicking on any of the button will show related options. Most of them we are seeing inaccessible right now because we do not have any project open. Below that is the ribbon bar, which is particularly important as it primarily allows us to select which module we want to use for our project. Apart from module selection, the ribbon bar provides access to multiple other functions also that we will be exploring as we move forward. Below ribbon bar, you will notice several other windows and a large gray area. Each window already has a title displayed in its top left corner, giving us a slight idea of what it is used for. However, we will be exploring those windows in detail as we proceed. The gray area changes depending on type of a module or design inserted. Until we insert a specific design, it remains gray. So let us start by inserting a new project. To add a project, click on the new button in the ribbon bar. Please make sure that the desktop option is selected in the ribbon bar. Otherwise, the new button will not be visible. Clicking on the new button creates a project with a green symbol named as a project 1. Now this is a default naming convention ADT follows. If there is already a project named as project 1, the new project will be named as project 2 and so on. You can rename this default name to suit your convenience. Like let's say I want to change this name to be test 1, and as you can see now the project name is changed to be test 1. Now once a new project is created, all the module becomes available to insert a design in our project. In our case, we are interested in Maxwell. So when I click on the drop down button below Maxwell module, you will notice that multiple sub modules are also there for the Maxwell itself. Now first we have Maxwell 3D, a dedicated 3D FEA solver generally used for performing 3D finite element analysis. This covers all the type of electromagnetic devices such as motor, transformer, generators, solenoids, etc. Following up, we have Maxwell 2D, which is dedicated 2D FEA solver, generally used for simulating devices or the machines which have third axis symmetry in terms of a magnetic or electric field distribution. Radial flux machines and the cylindrical actuators are the common example that we can consider for simulating it in Maxwell 2D. Then we have a Maxwell circuit, which can be used to create circuits that can later be coupled with Maxwell 2D or 3D to provide customized excitation for the simulation model, which is directly not possible with the uh, sine cosine based formula and all. At last, we have RM Expert, which is a detail level analytical solver for designing rotating electrical machines. So the design created in the RM Expert is purely based on empirical formulas, but it can be transferred automatically to Maxwell 2D or 3D to perform, a detail level finite element analysis. For this lecture, we will be focusing on Maxwell 2D. So let us insert a Maxwell 2D design. Once the design is inserted, the gray area transforms into two windows. One is called model tree or history tree, and the second is called as a 2D model. Now let us go through each window to understand its function. So starting with the project manager, as the name suggests, it manages all the open projects and the respective designs. Note that in one Maxwell session, a user can open multiple projects. For example, you could create a separate project for 2D and 3D designs, like say test one. Now, if I want to add another project, which is again project one, let's say I am naming that to be again test 2, saving it, and I want to add 3D over here. So this test one is the project 1, test 2 is the project 2, and in a test 1 we have Maxwell 2D design 1, in a test 2 we have a Maxwell 3D design 1. Additionally, it is possible to have a multiple design within the same project also. For example, if I want to add here Maxwell 3D design, if I let's say I want to add one other Maxwell 2D design, so you can see that we have 3 design in a single project. When working with multiple designs in a single project, to identify active design, look for the design which is highlighted in a bold text. For example, in this one, currently we have Maxwell 3D design 1 is highlighted as a bold. That means that is the active design. Let's say if I want to select it to Maxwell 2D design 1, so that will be highlighted as a bold. That means this is the active design. Now, additionally, we see a magnetostatic XY in bracket after the design name. The name magnetostatic suggests the solution type of the design, and XY shows the geometry mode, whether it is in Cartesian or cylindrical. We have already discussed about the solution type in our previous lecture. So extending the inserted design in the project manager reveals a detailed setup tree, which needs to be configured appropriately to perform accurate FEA. We will be covering each step in detail in upcoming lectures. Now, below the project manager, we have property windows. So property window is responsible for displaying all the properties of selected entities. This as well we will be exploring in more detail in upcoming tutorials, like based on which entity selection, what type of properties we are able to see. Next to property window, we have message manager, which shows all the warnings, errors, and other notification related to the model setup and the simulation process. The progress window beside the message manager shows simulations progress and provides a real-time update on how much simulation is completed and what is the status of our ongoing analysis. The model tree is responsible for listing all the geometrical entities, their material properties and coordinate systems, etc. It also records all the geometrical operations that we have performed on any of the components or any geometrical entities. Finally, 2D modeler or the GUI that displays the geometry that we have created using Maxwell modeler itself, or if we have imported using the third-party software. So this was an overview of the Maxwell interface. Now let us understand the 2D modeler in detail and other important feature of the Maxwell that we will be using throughout the series. So let us go through each of the modeling options that Maxwell has, starting from the 0D element. So if I want to create a point, let's say I will go over draw point option and I will click on wherever I want to place it. Now here you can see that I'm unable to see the points that I have created. But in the model tree, you will see that one list with the name of point is added. Extending it shows that point 1, which we have created. On the property window, you will see that what are all the properties this point 1 is consisting of. So what is the name, what is the coordinate system it has been used to create, color of it, and the position. Now say if you want to change the position, let's say I don't want it at there, I want it to be 110. I will click 110 and you can see that now the point is moved to 110. If you want to change the name from point 1 to let's say P1, then again the name is changed to P1. So one of the good thing with the Maxwell is that you don't have to always create each of the geometric operation or modeling to the exact location. Once you do it later on, you can edit as per your requirement. Now about 1D element. So say if I want to create a line, and just click on it, first click, second click. Once I'm done with that, I will click on right and then done. And that's it. I have my line ready. And if I want to again change the location of that, say 1 comma 1 comma 0, you can see that, and automatically that line segment will be adjusted. Similar to that, now let's say I want to create a spline. So wherever I will click, it will create a spline. Once I am done with that, I will just click and done. And you can see that it has created my spline. Similarly, I want to create, let's say, arc. So here we have two options for the arc. One is the 3-point arc. So wherever the 3 points I will put, then right click and done. So with that 3-point, I have arc created. Similarly, if I want to create arc with center on 2 points, so first will be my origin or the arc center. Second click will be the radius, and third click will be the length of the arc. Again, all those things I can change it if it is not placed at the right coordinate points. So for example, angle currently is 35.53. Say I want to keep it only 30 degree. So the moment I will change it to 30, you will see that the arc reduces to 30 degree. So everything in the Maxwell, what we are doing is flexible. Similarly, if you want to create a curve which is based on equation, so here you can create equation based curve. You will add all the dependency of x, y, z. You can assign a functions. We have a multiple possibilities of the function. Once you define it, you will have that equation based curve. Then let's say I will clear the GUI. I don't need this. Yeah. Now, if you want to create draw rectangle, so simply click Second click will create a rectangle. So here you can see that rectangle 1 is under the vacuum window, which means this rectangle 1 is behaving as a vacuum, or the rectangle 1 is assigned with the vacuum material. We can change it whenever we want, but by default Maxwell assign any of the object to be by default as a vacuum. Now when you select on the rectangle 1, it will show all the properties similar to that of the points and lines, etc. So what is the material, what is the orientation, what is the model, displaying color. If you want to change the color, say I want to keep it this one, then you'll see that the color will change. If you want to change the name, say box, and it will be changed as a box. So modeling side, we have complete freedom in the Maxwell, whichever the way we want to create it. Now say we want to create circle, so I will just click on the circle. First click will define my origin, and the second click, wherever I am doing, will define the radius. And you will see that in the model tree I have something that is named as a circle 1. If you want to change the definition, let's say I want to change the center position, I don't want it at 0.3, I want it at 0.5. Automatically that will move. Radius, say I want 0.8, so it will move it accordingly. Now in the circle we are seeing that there is something named as a number of segments. So whenever the number of segments in a circle is 0, that means it is considered as a perfect circle, which means there will be no segmentation created. Let's say if I assign a segmentation, so say I want to keep 36. So you will see that now the circle is created using 36 different segments. If I increase it to 360, you will see that it's nearer to that circle only, but still this is created with the segment. Now this is very important fundamental to know, as we will be using this number of segments quite a lot in our simulation. Currently I'm going to keep it 0 only. Now I want to create a ellipse, so I will just click it here, and then it will ask me for the second axis. If I want to change it, you can see that what is the center position, major radius, and the ratio to the major radius. Simply all the things are self-explanatory. Now if I want to create a polygon, I can create a polygon like this, and it is asking what number of segments you want to keep. So say I want to keep 3, then it will create something like this. Let's say I want to keep 8, like this. Click OK, and create a polygon. So these are all the basic modeling options that we have in the Maxwell. Now using these options, we will be able to do any of the complex geometry which we want to model in, that we will be looking at later on as we proceed in upcoming tutorials. But here we have to look into this further options. Now we'll move to these options. So as you can see, currently these are all not accessible, but the moment you click or the moment you select any of the object, you will see most of them are getting enabled on. So let us go through one by one. So if I select this box, first option is move. So if I will select on move, it will ask me for the direction. So first click, second click. So it will move this box or any of the selected object by the vector which I moved. If I want to change that, let's say I don't want to move it by 1.5, I want to move it by 3. So automatically I will change it and then it will move it over here. So you can see that under the box it has created one more option named as a move. So as we keep on modeling these geometries, we are seeing whatever the operations we are performing on it. For example, let's say we are doing same thing with the box only, but this time I'm going to rotate it. So I will rotate it. So what is the rotation angle? 90 degree, and rotation axis to be Z. So it will rotate along the Z axis by 90 degree. If I will rotate it, let's say 45 degree. So you can see that below that we have added an option rotate, and the properties of that rotation is also showing to be here. That angle is 45 degree. If I want to change it, let's say 90 degree, I can change it later on also, and you can see it is over here. Similarly, if I want to create mirror, means I want to move it by the mirror, so I will just click over here, and wherever I want to mirror it, I will just drive it, and it will mirror it along with that coordinate. Let's say I don't want to use this mirror option, so simply I can select it and I can press delete in the keyboard and it will remove that option. Similarly, rotate, I don't want it, delete. Move, again, not deleting. And you can see that all the things we have done came to a original position. So Maxwell is very flexible in this condition. Whichever the way you want to model it, you can model it. Now let's go through further case. So here this is our one object which I want to say copy. So if I want to create the same thing over here and I want to create a duplication. So let's say I'm going to use ellipse for this. So I want to create a copy of it. So you can see the first option which shows it as a duplicate along line. That means it will duplicate along a straight line. So if I will click on it and I'm just selecting a vector length, and here it is asking me what is the total number you want. So this total number is including the original. Say I want to create 5 number total, and I will click OK. So you will see that we have total of 5 ellipses created, 1 2 3 4 and 5, and they are distanced by this vector 2.2 comma 0 comma 0. If you want to create it in a different format, let's say I don't want it 2.2, I want it 2, and I will just click OK. Then you will be able to edit it using that values. Similarly, let's say we want to copy it along the axis. So I will just use the duplicate around axis. Say 90 degree, no, we want it 45 degree, and say we want 8. So you can see that it has created 8 different ellipses, including the original. Now if you want to remove any of the cases, again you can just simply use the delete option and it will create the remaining geometry as it is. Now you can see that the moment we deleted it, it showed us the respective messages that since we have deleted the operation, the parts that has been created using that particular operation has also been deleted. I want to just clear it out. Now, similarly, if you want to use the mirror option, this, this, and it will just create a copy in a mirror geometry. If you don't want it again, simply delete it. So this is the option which we can use to create multiple identical geometries. Now, remaining three options, as you can see, that is still not enabled. So first thing is unite. So as the name suggests itself, if you have multiple bodies that you want to unite it into single, so to have a multiple body, if you want to use that, you have to select multiple bodies. So here we are selecting with, let's say, circle and the box. The moment we selected two bodies, you see that all the options have been enabled. So here, first I selected box, second I selected circle 1. The moment I will click on unite, you will see that it converged into single object as a box. Now here it is important to keep in mind that whichever the body you are selecting first, that will be considered as a master and will hold its naming over here. For example, let me do it Ctrl Z. If I select the circle 1 first, and then if I select the box, and then if I do unite, now you see that here it is showing it as a circle 1. So I'm doing here, I will let it be united. Now there is a box 1 and we have ellipse over here. So here second option is subtract. So as the name suggested itself, from the selected option, the second option will be subtracted, or from the first selected body, second body will be subtracted. So here when we select on the subtract, it will show that the blank part. So blank part is the master part, tool part is the subtracting part. So here you can see that from the box 1 we eliminated the ellipse. So whatever is the remaining area, that we are able to see it. Now third one is the intersect. So if I have over here box and then we have polygon. So if I will select intersect, whatever area is the common for each of the case, that will be stayed over there. So you can see it is only named as a box 1 because from the start itself we are keeping the box as a master entity. Now this option split. So split is used to cut an object using a plane. So here only one is also sufficient one because we are cutting that object using the plane. So here I selected that object and I'm creating a split. So here when I'm selecting the split option, it is asking me a multiple options to choose. So first is split using plane. So currently we are cutting through YZ plane. What is the results you want to keep? Then split all selected object and delete invalid objects created during operation. So what each of the meaning? So here which plane you want to use. So for example, if I want to use ZX, so you can see immediately the arrow is changed. So here, whichever the side that arrow is showing, that side of the part will stay. Remaining side will be deleted. Let's say we want to create negative side. So you can see the immediately arrow changed to downwards. Now this time if I will click OK, so upper portion will be removed and only lower portion will be there. If I click both, then it will cut through that plane, but it will keep both the results in a separate entities. Say I want to keep it positive side, split all selected object. So whatever the options or whatever the object we have selected, all those will be splitted. If we click split select object crossing split plane, so if any of the object which we have selected, if it is not crossing the plane, then it will not split that. So if you want to keep it that way, you can keep it as it is. And we're gonna click OK. So you see only the upper portion is remaining. If you want to change it from here, negative side, so it will change to negative side. Okay. So these are all the options in modeling that we have. Imprint currently is not that important. We don't use that much in our modeling options in a 2D. In the 3D, it somehow comes to a very important, which we will be covering at that point. Now these are all the objects which we use for the 3D. Remaining two are fillet and chamfer. So fillet and chamfer is applying a fillet on any of the corners or applying a chamfer on any of the corner. Let's say I have this type of a rectangle and I want to create a fillet on this. Now here it is very important to mention that what type of a geometry selection we are in. So currently you can see that over here the selection mode is object. So whatever you are selecting, it will select the complete object. Now we know that we will have edges, we will have faces, and we will have even points or vertices. So in order to apply fillet and chamfer, we need to have vertices selected or points selected. So here you can see that in selection mode we have object selection, face selection, edge selection, and vertex selection. If you select multi, means all combined. So here I will go to vertex selection, and the moment I will select the vertices, you see that the fillet option and chamfer option is enabled. Let's say I am selecting only this 2 point, pressing Control, fillet. So it is asking me what is the fillet radius. Let's say I want to create fillet with 0.1 mm. So the moment I click on it, it will create a fillet with 0.1 mm. On the other hand, let's say if you want to create a chamfer, I will create 0.1 mm and we have a chamfer created. So this is how we will be using these options. Again, these options are useful for the 3D, which we will be covering it in 3D tutorial. Now, the important thing that comes is coordinate system. So coordinate systems are very important. For example, if there are any of the object we are not able to directly make using the global coordinate system. So you can see that on a model tree, currently we have only global coordinate system. So if you want to create another relative coordinate system, you can create it with the relative coordinate system creation. So this option allows us to create different coordinate systems to generate our model in an advanced way. So here you can see that we have three options. One is offset, another one is rotated, and the third one is both. So offset means whichever you are considering the reference or currently is in working mode. For example, currently the working coordinate system is a global one. So with respect to that, it will just create offset, means x and y and z will remain same. So let's say I'm selecting offset, and wherever I'm placing, you'll see that the xyz axis remains identical to that of the global. Only the origin is changed. Again, we can rename this like one, something like that. And if you want to change the origin to one, and we'll see that coordinate system shifted accordingly. And this time you will see that this is now changed to working coordinate system. Now if we create another coordinate system, it will be created using this as a reference. See here we have rotated, so it is only considering the rotation of axis, for example this. So you see it changed the x, y and z axis only, but the origin remained same as the reference coordinate system. So you will see like this. But let's say if you want to create a coordinate system that has both possibility, it has to be offset as well as it has to be rotated. So you will click both. So then wherever we will click, first it will ask that point will be the origin, and wherever we click on the second will be considering the x-axis passing through it. So this one you can see that relative CS2 is our coordinate system with the both option. Now here we have created three coordinate system, but these are all called as a relative CS. Another, we have two options, create face CS and one is create object CS. So what that means? So if you are using any of the object as a reference to place your coordinate system, that coordinate system is considered as a object CS. So let's say I am moving back to object. Now I'm able to select directly object. The moment I select object, you will see that the object CS option is enabled. Same option is enabled over here. Same both. I will put it over here and put it over here. So whichever the side I'm clicking on the first, that would be my origin. Wherever I click the second one will be my x-axis spanning from there. So you can see that here, this is my first option. Now similarly, if I move back to face CS, now this time it is selected as a face because we are in a face selection. So here you can see that it has enable of face CS. So I'm just selecting, placing it over here and then here. So you can see it has created a face CS. So this is how we will be able to create any type of a coordinate system that we want for our modeling options. Now, when to use which one, we will be discussing in detail as we move forward in upcoming lectures. Now, we discussed about the coordinate systems and creation of geometries and etc. But let's say if we want to measure some of the dimension of it, how do we do that? So let's say I want to measure the difference between this line to this line. So what I will do, I can first go to edge selection. Then I selected edge, so you can see one highlighted with the pink. And one thing that we can see is at the down right corner, one edge is selected. That is what it is written. So simply we selected one edge, we selected another edge. And then if you go to here in the measure option, it will show us what type of entities you want to measure, whether you want to measure object, face, or edge, or even a position. So if we click on the edge, it will show a dialog box, and here we are able to measure each of the things. Like for the edge 1220, length is 1.1. For the length 1231, the length is 1.1, and that is what is important for us. Minimum distance is 0.5 mm, which means these two lines are apart by 0.5 mm. Let's say we want to measure a radius of this edge, so we'll select the edge, measure edge, and that is radius is 0.1 mm, diameter is 0.2 mm. Let's say the length of this edge, so length of is 0.14142. So simply, if we want to measure the object itself, so I will go into object. Now here every time coming out to this and changing this can be tedious. So another way of going in a different selection mode is go over here, and you can see that for the object it is written as O, for faces it is written as F. So anywhere if you want to change any of the selection mode, you can still just press respective key in your keyboard. For example, you can see that here it is edge. Now if I want to move to object selection, I will just press O in my keyboard, and you can see that now it is changed into object selection. Now if I will select anything, it will select only in objects. So say I want to measure this object, so it is asking is the area of it, what is the volume. Since z is 0, volume will be 0, but area, you can see that we have it. So similarly here we'll be able to measure other aspect of our geometry. Now ruler, if you want to see it, you can see it. If you want to hide the grids, you can hide it. Generally I prefer to keep it both hidden. Units, if you want to change the units, you can change it. And let's say if you have mistakenly modeled it in mm, but you were supposed to model it in inches, so if you enable this option, and let's say I want it to be in it in inches, so now you will see that this edge is earlier it was 1.1 mm, but now it is 1.1 inch. So it converted that into the new images. Okay, if you don't want to change it, you can just let it be as it is. I want it in mm. Now 27.94. So dimensions have been changed. Now last options that we are seeing is this, like what is the selection mode over here. So here whenever you are, this is to help you out in how your cursor is going to direct it. For example, snap to grid, which means if you see any of the selection point, wherever I am going to keep, it will keep on automatically move in between the grid points only. If I will keep it disabled, then I can move it anywhere it is. Similarly, if I want to keep snap to face center, so wherever if I have any of the face center, then if I will move it over there, automatically it will find the center of the face, for example here. So the moment it is at the center of the face, it turned to circle. Okay, and this is where my point is. So this helps us in redirecting it to the points. Now about the visibility. For example, if you want to see all the options, then you will keep it all. Then whatever the geometrical parameters you have model will be visible. Say some of the option you want to hide it. Let's say for currently we don't want to see this box. I want to keep it, but it is affecting my designing and all. It is creating issue with my modeling. So what I'm going to do is I will just select it, and if I click on the hide selected object, so it will hide it. So you can see that the box is still there, but it has just made it as a hidden. Similarly, if you want to bring it back, select it and click on this, and then there it is. Similarly, if you want to see only those part which you want to work on, for example this one, so I will just select it and only that part will be visible, remaining one will be hidden. If you want to select all, it will show all the objects that is in the context. So these are all the options that we wanted to cover before we start with the actual modeling and going into the finite element analysis using Maxwell. So that's it for this lecture. Thank you all for watching this, and let me know in the comments if you guys have any question. Have a great day and see you in the next lecture. Cheers.